Okay, so I want to finish out the rest of the problem. The question was, what are the genotypic and phenotypic ratios of the offspring? Okay, so here is my Punnett square, and in order to figure out the genotypic and phenotypic ratios, I'm actually going to have to go through and I'm going to have to count how many I have of each kind. So we'll start with the genotypic ratio. Don't forget that when you're asked about a genotypic ratio, somebody is asking about how many you have of each kind. So just starting here in the corner, I'm actually just going to list them on my paper. So, and I'm just going to start right here and I'll continue on down here. So the first thing I have is I have capital G, capital G, capital R, capital R. I have one of those that I can see. Okay, and I'm just going to mark it. I'm going to put a little check mark once I do it. The next thing I have is I have a capital G, capital G, capital R, lowercase r, and I actually have several of those. I have one and I have two of those. Okay, the next one I have capital G, lowercase g, capital R, and I have, if I go to my list, I have one, I have two, I think that's it. And then the next one I have, and I'm just going in order, I'm going down the row, I have capital G, lowercase g, capital R, lowercase r, and I actually have 1, 2, 3, 4 of those. Okay? And then the next one I have is I have, let's see, capital G, lowercase r. I think I only have one of those. And then I have capital G, lowercase r, and I have 1, 2 of those. And then the next one I have is lowercase g, capital R, and I have one of those again. And then I have lowercase g, capital R, lowercase r, and I have two of those. And then the last one I have is lowercase g, lowercase r, and I have one of those. And that's the last one. So what I did is I went through and I counted how many I have of each kind. This is my genotypic ratio, okay? Typically on a 4-square Punnett, on a monohybrid cross, this is really easy. I can just tell how many I have of each kind. But here, it's a little bit more complicated. And like I said, when the parents are heterozygous, this is a worst case scenario. This is the longest one of them all, where you have such a variety, okay? So this is my genotypic ratio. Okay. Now, the second part of the question was, what is the phenotypic ratio? Well, since I did the hard part first, the genotypic ratio, the phenotypic ratio should be pretty simple. I've just got to record how many I have of each type. So for example, if I start with this first one with the dominant allele of capital G, is going to be green colored and it's going to be red. I mean, not red, it's going to be round. It's going to be green and round. And I have one of those so far. This guy right here is also green and round because it's got the dominant alleles for both. So I'm going to add that to my total. I have two more. The third one is also green and round. So I'm going to add two more. And then finally, the fourth one is also green and round. So I'm going to add 1, 2, 3, 4. So I have a total of 9. These first 9 are green and round. The next one is green, but the shape is no longer round. This is square. And I have one of those. The guy below him is also green and square, so I'm going to add two more. So I have 3 of those. The next one is no longer green. The lowercase g's, according to my problem, if I look back, those guys are going to be red in color. So those are going to be red. And they're going to be round. And I have one of those. But if I look at the next one, I also have, these guys are red, and they are also round, so I'm going to add 2 more. So I have a total of 3 of those. And then the last one is going to be red, and the shape is the only one that's going to be red and square. And I have one of those. If I go through and I've done this correctly, these should total 16 because that's how many squares I had. So these 5 plus 4 is 9. There's 3 of these, there's 3 of these, and there's one more. When I go through and I total, I'm correct, and I have 16 total squares. This is the phenotypic ratio of the offspring. You will have 9 green and round, 3 green and square, 3 of them will be red and round, and 1 will be red and square. Okay? And then question number 2, what is the probability that a plant will be red and square? You have a question number 2, you have the probability of 1 in 16 that your plant will be red and square.